Hello everyone. In this video I'm going to review some more examples of proving trig identities. This is a different one. And as I've said in previous videos, with trig identities, again, the way I show you is a way that will certainly work, but understand it's not always the best, meant to be the preferable way for you, and it's not necessarily the only way to do it. And I'm going to try to show this in two different ways, so we can see the comparison between the two. And again, as I said before, trig identities, there's no necessarily one way of doing these, again, and there's no algorithm for it. So as I go along, I'll try to say some general statements as far as things you can try, and hopefully that will help you in the problems that you try yourself. This one, for example, sine of x plus 1 over cosine plus 1 over cosine over sine equals 2 cosecant of x. Now I have two fractions on my left side. Now I'm going to pick that side because it's more complex. Usually it's easier to do. Usually it's easier to start with a more complex side because you have more to manipulate. I'm going to say, well, I like it when I have a single fraction. So let me try to get these as a single fraction. So I'm going back to algebra. I need to find a common denominator. In this case, it's going to be sine of x times the quantity 1 plus cosine of x. So to get a common denominator, I need to multiply my first term by sine of x, the numerator and denominator, and my second term by 1 plus cosine of x as a quantity to the numerator and denominator. So let me move that so I have some room. Now I'm going to do that. Sine of x times sine of x will give me sine squared of x. Plus, now I have 1 plus cosine of x times 1 plus cosine of x. So I'm squaring that quantity, which means I'm going to be foiling it. So really I'm saying, what is 1 plus cosine of x times 1 plus cosine of x? So if we FOIL it out, we'll have, I'm just going to rewrite my sine squared of x. I'll have 1 plus 2 cosine of x plus cosine squared of x. So this is in my numerator right now. And again, I got the 2 cosine of x from, if I did my FOIL, I'll have a 1 times cosine of x, of course is 1. Cosine of x times 1 is, of course, cosine of x. Cosine plus cosine gives me 2 cosine of x. Now what we also have in our denominator is the LCD. Sine of x times 1 plus cosine of x. Now I'm not going to multiply it out, because in factored form sometimes it makes things easier to see and manipulate. Now what I'm going to do is I'm going to erase that, because 1, I want a little bit of space to do some work, and 2, we know that's going to be the denominator overall. So let me see what I can modify up here. I can say that my cosine of x and sine squared of x, since it's all addition, one of my properties is sine squared of x plus cosine squared of x equals 1. So since I have both parts, I can say now that these will both add up to 1. So now instead I have 1 plus 2 cosine of x. Well, I can make that 2 plus 2 cosine of x. And again, reminder, this is still in our numerator. My denominator still stands as sine of x times 1 plus cosine, but I want to manipulate my numerator as much as I can. And hopefully, that denominator will make things easier for me. So now I have this. Let's see, well, there's no properties that I know. There's no trig substitutions I can use. I can, however, factor out a 2 from this. So let me go over here. So now I have 2 times 1 plus cosine of x. Can't do much else with that. Over my denominator of sine of x times 1 plus cosine of x. So obviously this works out nicely. And if you didn't know to factor that from the beginning, if you put 2 plus 2 cosine of x over our denominator, things you want to look for are you might think, is there a way I could match it up? Is there a way, for example, if you had, if you had this, and you didn't think to first of all to factor out your 2. You want to think, well, the 2 plus 2 cosine of x is close to the term in my denominator. You want to think, is there a way that I could manipulate that, factor it, do whatever, so that those two would match up? That way I could cancel them out. See if I can make things simpler. And hopefully that will lead you to try to factor out your 2. So now, I can cancel these out, and I'm left with 2 over sine of x. Now I want, if we go back up here, what I want is 2 cosecant of x. Right now I have 2 over sine of x. And if we think back to our definitions, 1 over sine of x is the definition of cosecant. So I can therefore say that this is 2 cosecant of x, which is, again, what I want. So you can see the way I did it here. I have 2 fractions, so I thought, let me combine these and see what I can do. I manipulated, multiplied, combined, and did some identities. Got my 2 plus 2 cosine of x, factored out the 2, canceled, and then by definition I made it 2 cosecant of x. Like I said, this is one way of doing it, which works. Let me try to do another way. I'm going to say, same problem. I say, what could I do? Well, I could say, if you remember back from algebra, I can take this and find the conjugate of it, which is 1 minus cosine of x. And I'll multiply that times the denominator and the numerator just of the first one. So I'm saying, let me just manipulate the first one. So if you remember from algebra, 1 plus cosine of x times 1 minus cosine of x is the same property as saying x plus y times x minus y to give me x squared minus y squared. So in the same way, 1 plus cosine of x times 1 minus cosine of x would yield me 1 minus cosine of squared of x. And I still have sine of x times 1 minus cosine of x in my numerator. While using my identities, from our identity sine squared of x plus cosine squared of x equals 1, I can take from this that sine squared of x is equal to 1 minus cosine squared of x if I subtract cosine of x from each side. So based off that, I can make a substitution and say now this is sine of x times 1 minus cosine of x over sine squared of x. I still have this over here. I've just been manipulating my 1 fraction. Now I can say, well, I'm actually pretty close to making these have the same denominator. If I just multiply my second part by sine, then I have a common denominator of sine squared. So I'm saying I'll multiply sine of x times 1 plus cosine. So let me rewrite what I have in my numerators now. From the first fraction I have sine of x times 1 minus cosine of x plus from the second fraction sine of x times 1 plus cosine of x over my sine squared of x. Now like before, let me work with my numerator. Let me manipulate that and then see where it takes me. So what I'm going to do is let me take this and we'll try to move this to our next slide. I need some more room. So here we go. So like I said, I'm going to just focus on my numerator for now. So if I distribute my sign and this sign as well, I'll have sine of x minus cosine of x sine of x plus sine of x plus cosine of x sine of x. And let me try to make that halfway legible. So again, after distributing my sine of x minus sine of x cosine of x plus my second part, sine of x plus, again, sine of x cosine of x. So again, I'm just manipulating my numerator. What can I simplify? Well, I can say that negative sine of x cosine of x and positive sine cosine of x will add up to 0, so I can just get rid of them. Sine of x plus sine of x will give me 2 sine of x. Not sine squared of x, because I'm adding, over my sine squared of x. I can reduce. I have essentially 2 sines in the denominator, 1 in the numerator. I can cancel 1, and I'm left with 2 over sine of x, which by definition is the same as 2 cosecant of x, which is what I wanted. So I've gone over 2 ways of approaching this proof. The first way by combining my 2 fractions, the second way by manipulating one fraction and then combine it with the second. 2 equally valid ways, and again, doesn't matter, as long as you're following rules, your identity works the same. So there's 2 ways to get you thinking about how to approach proof problems.